Today I will talk about the implementation of a SLE-based external DNS solution for Kubernetes for a recent project I have worked on. In this session, I will be sharing my experience using the SLE-based container images to build several containers used to implement an external DNS solution for a recent project I have worked on. I'll provide a short demo at the end of the session. My name is Keith Berger. I'm a senior software engineer at SUSE. I've been at SUSE for 6 years. I work in the Cloud Solutions Engineering organization and work on various projects related to our public cloud portfolio. Recently, I was also part of a team working on the Rancher Bare Metal project. This project involved container images, K3s and RKE2, and Helm charts. This session will highlight my involvement in the DNS part of the Bare Metal project. These are the topics I will cover in today's session. What is the problem needing to be solved? What solution will be provided? First steps. Power DNS. External DNS. Helm charts. Support tools and troubleshooting tips. A demo, and then questions. What is the problem needing to be solved? The Rancher Bare Metal project uses the Ironic service to handle the bare metal deployment to the edge nodes. In order to provide a flexible solution and be compatible with Kubernetes English resources, the Ironic endpoints are configured with host names and not IP addresses. How can we dynamically create the host names when the Ironic services are deployed? How do we ensure the DNS records match the current state of the English resources? What solution will be provided? The initial prototype of the Rancher Bare Metal project was designed using external DNS. External DNS provides the ability to synchronize exposed Kubernetes services and Englishes with a customer's DNS provider. The initial design of the bare metal prototype used an Alpine image to run external DNS. It was configured to integrate with Cloudflare as its DNS provider. The goal of this project was to convert this prototype to a solution based on SLE containers and use a local database option. The first steps. The first part of the investigation was to see which self-hosted DNS options are available in OBS. Once that was completed, the next step was trying to create containers for external DNS and the supported DNS solution. Power DNS. One of the DNS servers supported by external DNS is Power DNS. Power DNS has two separate packages. A recursor handles name resolution and is pre-configured to use the upstream root name servers. A second package, the authoritative server, provides a whitelist function such that the recursor can forward specific local domains to the authoritative server for resolution. This whitelist is part of the recursor's configuration. In addition, Power DNS requires a database to store its DNS records, and SQLite3 is one of the supported options. Examining OBS showed packages exist for the recursor, the authoritative server, and SQLite3. With these packages available, Power DNS was chosen as the DNS solution for external DNS. With Power DNS packages already in OBS, it will be easy to leverage the existing SLE BCI container images. The investigation and testing phase revealed some areas that needed to be addressed. The first item was while the recursor will listen on port 53, the authoritative server should listen on some other port, as it is only accessed from the recursor. In addition, the PDNS utility should be available as it facilitates easy initialization of DNS records and allows for record modifications. This can be used, for example, to delete a record to test it gets automatically recreated by external DNS. During the test deployments, a few issues arose that needed to be addressed. The first issue was realizing we need two containers and not one. This is due to differences in the version numbers of the PDNS recursor and the authoritative server in OBS. How would we track the image version if there were two variables? By splitting this into two containers, one for the recursor and one for the authoritative server. Each container version tracks the installed package version. A second issue was related to changing permissions on the SQLite3 database files and directories. When the container is deployed using a Kubernetes deployment or Helm chart, there were issues when the permissions of the SQLite3 database directory were changed to the pDNS user. This was solved using a helper container that is run at startup as a privileged user and executes the required change zones and change mod commands and then exits. The final issue was finding a stable version of PowerDNS in OBS. Initially linking to the server DNS project or OpenSUSE factory project resulted in the container being frequently updated. It was discovered that the OpenSUSE backports SLE-15SP4 project contained a stable version that did receive CVE patches. The container images are now published under the ISV Metal 3 BCI project. These containers can be switched to an OpenSUSE base by changing the front entry. External DNS. External DNS is a Kubernetes add-on that allows the creation of dynamic host names from Kubernetes ingress objects and certain service types. It supports integration with a wide variety of DNS providers and servers. External DNS is a Go application. The upstream version of the external DNS container is based on Alpine Linux. Additionally, this container has shell access disabled, which disables any troubleshooting other than the console logs. For example, ensuring it can connect to the configured DNS server it is using to create DNS records. Fortunately, there were many good examples of building Go applications in OBS to use as a reference. The K9S package in OBS is a Go application, and that was used as an example to create an external DNS package. Once that was done, the same method used to create the PowerDNS image was used to create the external DNS container image. The external DNS package is now published under the ISV Metal 3 project, and this contains the external DNS binary. The external DNS container image is now published under the ISV Metal 3 BCI project, and this is based on a SLE container. As mentioned before, these can be changed to an OpenSUSE base by changing the from entry in the Docker file. Helm charts. The Rancher Bare Metal project has an example of the Helm charts used to deploy PowerDNS. For external DNS, the Bitnami chart was used, but the Alpine image was replaced with the SLE-based external DNS container. Support tools and troubleshooting tips. During the development, I became familiar with K9S. It is a very good TUI, and I would highly recommend it. It just needs access to a kube config file. During development, it was convenient to be able to modify the Docker files to include certain tools that help verifying operation and troubleshooting. For example, bindutils, curl, and enabling SSH access. Once the container is ready for publishing, these extra tools can be removed. I will now do a short demo. In this first part of the demo, I'll review some of the repos that I covered in the slides. This first repo is the one for external DNS itself and provides some information about how it works. Most importantly, you'll see here that PowerDNS is listed as one of the supported DNS providers. The next repo we'll look at is one of the OpenSUSE backports, and here you can see that under inherited packages we have pDNS and pDNS common. And as I mentioned, we used OpenSUSE backports because that particular repo is more stable, but still gets CVE patches. The recursor is in the same repo, but it's listed under packages and not inherited packages. The next repo that we'll look at is for SQLite3. As I mentioned, pDNS requires a backend database, and so because SQLite3 is available in OBS, that is the one that we decided to use. So now we'll go look at the Docker files that we use to create the container images. So for this container here, this is the pDNS recursor image. It's a pretty standard type BCI file using a Docker file. The important thing is that we're having this run on port 53. And as I mentioned, the recursor is the one that handles all of the DNS name resolution requests, and it forwards them to the root upstream servers. other than those that are configured via a whitelist, and it forwards those to the PDNF authoritative server. We define that in the Helm chart, and I'll show that in a few seconds. The next repo is the actual PDNF auth server, and we've called this PDNS SQLite 3 since we're using the SQLite 3 backend. Again, very similar to the PDNS recursor. We provided, we installed things like bind utils and Vim for convenience. But you notice here that we're actually going to listen on port 54. And again, that's because I mentioned that the only thing that will contact the authoritative server is the recursor. If we look at the Helm chart for PDNS, you'll see that we set up the port for Power DNS to port 54, and we set up the recursor on port 53, and we set up our forward zones. And so this tells it, where to forward it to. So it's the values of the Power DNS authoritative port. So it'll know to forward it there. And then we've also created some default records here. The next repo we'll look at is the actual external DNS package. And this is just a standard spec file. As I mentioned, I used K9 as an example to build this. And then the next repo is the actual Docker file for external DNS. Again, this is also very simple, but as you see again, we installed bind utils in Vim to allow for additional troubleshooting. And then the final repo I'm going to show is the chart for how we deploy the external DNS. As I mentioned, that we're using the upstream Bitnami chart, but when we use that, we override some values. And so one of those is the repository here. And then also we provide information about which provider we're going to use. So instead of, as I mentioned, the initial prototype used Cloudflare, but now we're using PDNS. And then we provide some information about how it accesses PDNS, and then also the policy method, whether we sync records. This concludes the first part of the demo. In this second part of the demo, I'll show the deployed solution. The first thing you can see is that we have a couple containers running here, or pods, I should say. We have a Power DNS one, and we have an external DNS one. If we look at the Power DNS container, you'll see that there's actually 3 containers. There is a recursor container here, and our auth container. And then, as I mentioned earlier, we had to have a startup container that changed the permissions. And that's what this initdb script does. So you can see this one has exited with exit code 0, which is expected. And these other 2 containers are running. And you can see that they're pulling our images from OBS. You can also see the ports that I mentioned. So the auth server is running on port 54. Port 8081 is the API interface. And the recursor is running on port 53. If we now look at external DNS, you'll see that external DNS is also using our container. And you can see all the values that we provided. So, for example, the provider, the policy, also our PDNS server, and our API key. And this will let external DNS talk to the PDNS web interface, and it uses a REST API for that. Now we'll do a lookup of a record that's already been created. So this is our media server. So media.suse.bare-metal, and it resolves to this address. And now we're going to go ahead and try and remove this address and then watch what happens. So I've now shelled into our container. This is my PDNS container. As I mentioned, I can use PDNS util, and you'll see here that we're listing the zone and we have a media entry right now. Now we'll go ahead and we'll edit that. Now we can use PDNS util edit zone. And what I'll do is I'll go down here and I will delete this record. Okay. And it's going to ask me if I want to update. And I'll say yes, and it asks me if I want to apply. And so that's good. So now I'll do a list zone again. You can see that it's not there. So now let me exit. And now we'll do a lookup, and you'll see that it's not there, which is expected. So now I'm going to show you K9S. So if we go into K9S, we can go to our external DNS, and we can look at the logs. And you'll see right here that notice that that record is no longer there, and now it is creating it. So it created it right here. Now we'll get out of K9S. We'll do another lookup, and you see the record is back. And so that's how external DNS works. This concludes my demo. Thank you for attending my session.